Forecasting is a very important activity for any business or even government because based on the forecast, future planning is developed. If the forecasts are not accurate, obviously it will have an adverse impact on the activities that are planned based on the forecast. So having a good forecast is really important for success of any organization. There are different types of forecasting techniques that we are going to cover in this chapter. First one is called qualitative methods and second group of methods is called quantitative. As the name indicates, qualitative methods are based on qualitative information. So people who have been working for a long time in a company develop a lot of expertise in certain things and that could be a good source of information. Similarly, people with the technical know-how can also bring a lot of information that can help towards developing good forecasts. Similarly, experience and also intuition can be a good source that can help in developing good forecast. But as you can see, all these are qualitative and it can vary from one person to other person. One of the qualitative methods is called Delphi method, in which a set of questions are developed and shared with a group of people with certain expertise, and depending on what answers are received, there are adjustments made to the questions and the opinions are sought from the same group again, and this process is iteratively repeated till the group arrives at a consensus estimate. Another qualitative method involves executive opinion. So senior management of a company have a lot of insight and valuable knowledge about the business they are in, and that's very useful for predicting or forecasting. However, there is one major disadvantage, and that could be that in a meeting of senior executives, only one or two people dominate because of their position or strength in the company. Another source for forecasting demand is Salesforce opinion. Because Salesforce people are very close to the customers, the opinion they have is very valuable and sometimes very accurate also. The only disadvantage could be that they may underestimate the demand so that they are able to meet the target more easily. So apart from executive opinion, Salesforce opinion, another way is to directly contact the consumer and conduct a consumer survey. Quantitative methods can be classified broadly into two categories. One is time series and other is causal methods. As the name indicates, for time series methods, one of the variable obviously will be time. So some of the time series methods are listed here. We are going to look at examples very soon. Similarly, for causal methods, we can have like linear regression or multiple linear regression. In linear regression, we have one independent variable and one dependent variable. In multiple regression, we could have one dependent variable and several independent variables. Let's look at certain ways of assessing quality of the forecasting model. When we have several methods or several forecasting models available, it is important that we choose the right one that has a good quality in terms of making accurate forecasts. There are three methods for assessing forecasting accuracy which are very popular. One is mean absolute deviation, other is mean square error, and third one is mean absolute percentage error. Let's look at one example using POM for Windows. So let's choose forecasting under the modules and then open a new time series analysis. The data I have is for bicycle sales for 6 weeks. So I will change this to 6 and then say OK. So let's enter data and then I'm going to choose linear regression method. We then enter time from 1 to 6 and we want to do forecasting for time period 7 and then we click solve. In no time we get this forecasting accuracy calculations done, and you can see that there are values for MAD, MSE, and MAPE. So when we have several methods of forecasting and we assess the forecasting accuracy, we select that method that provides us lowest values for MAD, MSE, and MAPE. You can look at details about the calculations by clicking on the details, and you see how these calculations were made. The first component is called trend. It can be denoted by capital T. So let's say you have time on the x-axis and demand on the y-axis, and it is increasing with time. There could be some small fluctuations, and in this case the trend is positive because it goes up with time. The trend also could be negative. If it comes down with time, then we have a negative trend. Second component is seasonality, denoted by capital S. So there are some products that could be more popular or may have more demand in summer compared to winter, whereas some other products might have opposite demand. So the graph for seasonality may look like this. Cycles are more long term than seasonality. So instead of months for cycle, I will make use of years. Fourth one is random variation, represented by capital R. So as an example, with the trend, you could have this spike or a random variation because of certain reason. There are two types of models based on these four components of time series. One is called multiplicative model and other is additive model. We will look at examples of each one of them. Let's consider this data. For 2 week moving average, will not have any values for the first 2 weeks, and for the third week we use values from the first week and the second week. So we add them and divide by 2 and we get 9. We proceed like this to calculate other values. So for the 7th week, the forecasted value, which will be 10 plus 13 divided by 2, is 11.5. We also make use of naive method to come out with a forecast that we can use to compare other methods. So this is very simple. In week 7, the forecasted value is going to be whatever was the actual sales in week number 6. So 13 is going to be the forecast for week number 7 using naive method. In some situations, a naive method of forecasting could be good enough, but this is not going to work in every situation. Coming back to moving average, we can also add weights to the data points. So for example, in 2 week moving average, we treated 2 weeks of data points with equal weightage. But sometimes we may feel that the latest data point should get more weightage. So how to do that? Let's see. So let's give weightage of 2 to the last week data point and a weightage of 1 to the 2 weeks ago time period. So let's create another column. So we have 1 times 8, this is 8 and this is 1, plus 2 times, so we are using weight of 2 for the recent data point, times 10, which is the data point for the second week, and this whole thing is divided by the total weight 3. We can repeat the same process for the remaining weeks, and this is what we get. So using these weights, our forecast for week number 7 will be 12. Exponential smoothing is another method to provide weights to the data points, and this is the formula that is used for doing so. Here alpha is the smoothing constant and it lies between 0 and 1. So if the value of alpha lies in this region, so if it is close to 0, it means we give more weightage to the past data points, and when alpha is closer to 1, that means we are giving more weightage to the recent data points. YT is the actual data point in period T, and Ft is the forecasted value for period T. So let's apply this formula to this data. So we want to calculate forecasted value for the month of March, which is Ft plus 1 or F3, and it is going to be 144.2. In this equation, this Tt is trend correction term, and the value for the next period is calculated using this formula where beta is the smoothing constant, and the interpretation is similar to what we had for alpha. For trend projection, we use a regression where we have the straight line equation, and in this straight line equation we have a y-intercept represented by b0, and we have a slope represented by b1. We'll make use of seasonal index for this forecasting. Let me make up a data set as given below. So this data set shows that in January and February and also November and December, number of engine failures are higher compared to other months. Let's calculate average failure per month. So to get this average, we divide 240 by 12 months, which comes to 20. 20 in each month indicates that if there was no seasonality, then we would have seen about 20 failures every month. Let me number these columns as 1, 2, 3, and then fourth one I'm going to use for average seasonal index, which will be column 2 divided by column 3. So the first value is going to be 40 divided by 20, which comes to 2, and the meaning of this 2 is compared to an average month. In the month of January, we are likely to see 2 times more engine failures. Similarly, for the second row also we have 40 divided by 20, which comes to 2, and similarly we compute all other values. So using this average seasonal index, let's do prediction for the next year, assuming that we have more vehicles, and let's say engine failures are going to be about 480 in total, or about 40 per month. So now what we can do is we can multiply this 40 by the seasonal index 2, and for the month of January we get 80. Similarly, we can find out or estimate for each month how many failures are expected. This is a very simple example to illustrate use of seasonal index. So we have data on 4 quarters for 4 years. So there are totally 16 periods. So we change this to 16. We use multiplicative decomposition seasonal model. For number of seasons, because we have data on 4 quarters, we choose 4. And basis for smoothing, we are going to go for centered moving average, which is required in this problem. Next, we click on solve. So it quickly gives you the results. So it has calculated the errors, MAD, mean square error, or MAPE, and we also have the forecasted values. So you can see you have forecasted values from 17th quarter onwards up to 30th quarter, and it also gives you unadjusted forecast, which doesn't include the seasonality. And in fact, in the next column you have seasonal index, similar to what we did earlier, and by multiplying unadjusted forecast and seasonal index, we get the adjusted forecast value in the last column. We can also look at the detailed calculations. Similarly, we can also look at the graph, which provides you the actual values and predicted values. And you can see the actual values are for the 4 quarters, And when you go from first, second, third, and to the fourth quarter, there's always an increase in the fourth quarter compared to first three quarters. So if we fitted a model where we ignored the seasonality, then our prediction would have been the flat line, and that would have been very inaccurate when you look at the individual months. And since we have incorporated seasonality, our forecast given by the blue dotted lines you can see are much more accurate. So in this example we have used multiplicative model. So we can use the same data set and perform additive decomposition. So in this model x1 will represent time, and we can also add x2, x3 and x4, three variables to represent 4 quarters. So how do we represent 4 quarters using three variables x2, x3, x4? It's very simple. To represent quarter 1 we can use 0, 0, 0, and similarly to represent quarter 2 we can use 1, 0, 0, and for quarter 3 0, 1, 0, and quarter 4 0, 0, 1. So these three variables x2, x3, x4 are also called dummy variables, which is the technical name given to these variables. So I have used this format to enter this data in Excel, and this is how the data looks like in Excel. So x1 takes values from 1 to 16, which are different periods that we have, and x2, x3, x4 they capture various quarters, like when it is 0, 0, 0, it's the first quarter for each year. And our y, or the dependent variable, is revenue. So using this we can do multiple regression. To develop a multiple regression model, we can click on data and then data analysis. If you have not used this earlier, you may not see this data analysis option. So in that case you'll have to add in this from the tool pack. So for that, go to file and then click on options, and there you'll see add-ins. So once you click there, so it takes you to this screen where you can say add-ins, Excel add-ins, and click on go, and then you should check first two options and then click on OK to activate data analysis. So now we can click on data analysis and then go to regression. So once you choose that, on this screen we have to identify input y range and input x range. So y variable is revenue, so I'm going to select that, and then x range is all x1, x2, x3, x4, so I will select entire data set. And then since we have the labels or the titles for each column, I'm going to check labels, and in the next field we have confidence level. So 95% is default, so I'm going to choose that default value, and then let's say I want the output range to be somewhere here, so I choose that and then say OK. So this is the output, and multiple R is 0.98, quite high, and R square is 0.968, which indicates that about 96.8% of the variability in revenue is being explained by the model. So next, if you look at significance F value, it's very small. It's much lower than 0.05. So 0.05 would have been 95% confidence level in concluding that this model is significant. Because this is much below 0.05, we can safely conclude that this model is very significant. So now we can use these coefficients, which are B0, B1, B2, B3 and B4. So using this we can write down equation of our model. So now it's very easy to use this equation to predict, let's say x1 equals 17th period, and note that x2, x3, x4, all three will be 0. So when you do the calculation, you'll find that y equals 268.63. So if you compare this outcome to the previous model that we used, which was multiplicative model, and if you look at the prediction for the 17th time period, it was about 264.79. So you can see that the results are very close to each other for period 17. So you can see that these are two different approaches for arriving at a forecast gives you slightly different results. What one can do is calculate MAD, MSC, MAPE, etc., and whichever model gives the lower values, one can use that particular method for prediction. So once a model is developed, it has to be monitored, and if necessary, it has to be controlled so that it remains valid after a certain period of time. For this, we use tracking signal, and this is similar to control charts with upper and lower control limits. And the value to be monitored is MAD on the y-axis and time on the x-axis. So if the value lies within the limits, within the upper and lower control limits, then obviously everything is fine. As soon as the value falls outside the range, that is an indication that some adjustment to the model is now necessary and the earlier model is no more valid. Now calculation of the control limits depend on the situation. We use plus minus 4 MADs if we are dealing with high volume items and plus minus 8 for lower volume items. So you can also see this calculation in the earlier example that we were using. So if you choose control within bracket tracking signal and click on that, it will give you the calculations very quickly. So in forecasting, although there is a lot of data crunching, but this is also an art, and I will end this with this famous statement. So it only means that no forecasting method is like 100% accurate, but obviously we can find some method to be more useful than others.